Good evening, everyone, both online and here in person. My name is Scott Britton. I'm the Executive Director here at the Castle. I want to welcome you. Whoops, I guess how about that? Better, Kyle? Cutting my head off online there. Want to welcome you to our third Thursday presentation this evening. And this one is going to be a hybrid program. We do have some weather issues, but we're doing this hybrid both online as well as here in person. For our in-person audience and the online audience, we'll take all the questions at the end. So please save those for the end. We ask that those that are online submit the questions in either the chat box or the Q&A that's on their Zoom panel there, and we'll get to those at the end. One other thing for those in person, if you can check your electronic devices and make sure it doesn't give that happy tune to interrupt our speaker, we would appreciate that. At this time, I'm going to call to the podium Dr. Matt Young, who is a former board member here at the Castle, who will be introducing our speaker.
Thank you, Scott. Well, I'm hopefully in the right position here for everybody who's online. Welcome everyone to the presentation tonight. I'm really excited to introduce a former student of mine, actually also a current student of mine, Adrienne Hammontree, who is a junior, let me get this right, planetary science and geology major with a GIS minor. And really, that's the reason she's here tonight. I am a member of the history department, but I also developed and direct our GIS minor. And in case you don't know, GIS stands for Geographic Information Systems, which is sort of the simple way to describe it is digital mapping, using software to make maps and do analysis, right? It becomes a very powerful research tool. And I teach an intermediate GIS course every spring, which Adrienne took, required for the minor. And part of that then is a research project, an independent research project where a student comes up with a topic and needs to apply the GIS skills that they've learned in the course. So Adrienne's going to tell you about the topic was the history of the new Concord Meteorite fall of 1860 and the modern mapping of its fragments. But it was just a fantastic idea that she came up with. And when she described it to me, I thought, oh, this is great, as you'll see. Very interesting stuff. And worked closely with, I need to acknowledge Linda Showalter, Marietta College archivist, who knows our special collections and is such a tremendous resource for our students. And so then we are literally the college sitting on a great repository of historical material, which Adrienne used and which she'll tell you about. So I'll get out of the way so she can present. Thanks.
Okay. Am I in frame? Maybe. Yes. Okay, cool. So good evening, everyone. My name, like Dr. Young said, is Adrienne Hammontree. He kind of stole all of my intro a little bit, but that's okay. Yeah, so I'm a planetary science and geology major at Marietta, also with a minor in GIS, which will be very prevalent in what we're talking about today. A lot of the research that I do is with meteorites. So I look at usually their chemical compositions, things like that, what they're made of, what minerals they're made of, things like that. And it's really cool stuff that we get to do at Marietta. But today we're not talking about that. We're talking about this lovely project that I did a year ago now, which is crazy to think about. That's really cool. So to get started, maybe. That's not it. Anything? Sure. Hello.
The thing is not plugged in.
Oh.
Don't see the piece. Sorry about that.
No, you're
Fine.
good.
Just hit the enter key and it'll Feels like you went through, but for whatever reason, it's not there.
I'm hitting all the buttons.
I think it's frozen.
It's okay.
It's good and better.
Oh,
Ah,
okay.
yay. Okay.
Sorry.
Anyway, no, you're okay.
See that over.
Aha, perfect. Okay. Back to your regularly scheduled program. So a little bit overview of what we're going to be talking about today. So I am going to be talking about my lovely project that I did. We're going to briefly cover the difference between a meteorite fall and a meteorite find, because they are two different things. Go over the meteorite, New Concord Meteorite Fall of 1860, and discuss some of the papers and stuff that came out around that time that describe the fall. Looking at the project that I did, mapping all of the fragments, and then we'll have time for questions at the end. So to get right into it, what the heck is a fall and a find, right? So falls, when a meteorite is falling through the atmosphere, a fall is classified as when someone sees that meteorite falling through the atmosphere and we can see it, it falls, right? Finds are classified when nobody witnesses that fall, right? So we find meteorite on the ground, pick it up, look at it, be like, oh, it's a meteorite, cool. And that's classified as a find. So in total, we have over 84,000 meteorites just known. I'm going to make you guys participate a little bit. Out of that number, how many do you think are falls? Any number?
10,000.
10,000?
1,000.
1,000. 42? 100. Okay. Well, 1,000 was actually pretty accurate. So yeah, you win for the day. There are only about 1,400 recorded falls, which only makes up about a little bit over 1.5 of all known meteorites that have been found this way. So it's pretty cool. So these are kind of rare-ish, if you want to kind of put it into that category, which makes the New Concord Meteorite Fall a little bit more interesting. So excuse me while I flip my notes here a little bit. This event happened on May 1st in 1860, so a little bit a while ago. So when this happened, it was around a little bit after noon, right before 1. A lot of people were in their homes, away from their fields, having like lunch, things like that. So they were inside, and a lot of people heard just loud bangs all of a sudden, right? So this thing was moving very, very fast, and it actually broke the sound barrier. So it was moving about 4 miles per second, if some of the papers described it, which is very fast. The speed of sound to break the sound barrier is about 0.2 miles per second. So this thing was moving. And it was heard from about 150 miles away, which is pretty far. Witnesses around the area did describe the sounds as like cannon fire, steamboat boilers, like going off. Some people even thought that it was an earthquake happening because it shook the windows and like the doors and things like that, which is crazy. So a lot of, ooh, where am I going? When this happened, there were about 23 loud sounds that were reported happening. So which later we can contribute to the amount of stones that were then broken off of the main mast, which is pretty cool. And then just a fun little tidbit. One of my favorite descriptions in some of these papers describes the sounds as an awkward squad of soldiers firing. So that's kind of one of my favorite little tidbits in these papers. These papers are so fun to read, by the way. If you go back and read old academic papers, they're very, very interesting. So anyway, after these locals heard these sounds, they went outside to investigate what happened, and they were actually able to see what they thought were black specks or black birds in the sky, which was very interesting. When observing these black specks, you could see them fall, and so when they saw them fall, they would be able to run and grab them. A lot of them, when they were found, were still hot from when they were falling through the atmosphere. A lot of them had a sulfurous smell around them, so they were actually able to smell like the stuff that was burning off of the meteorite, which I think is cool. And there are a lot of fun stories that came about from this, some of which are one struck a fence post, and then a couple struck it in 2 places. So one hit at the bottom, one hit another one. So that's pretty interesting. This meteorite is also famously kind of accused of killing a horse, like one of the stones struck it. That is speculation though, so I don't know if that's confirmed or not. I don't think it's real, but that's my own little tidbit. But yeah, most of these stones when they were seen falling were picked up within the first 20 to 30 minutes. And their locations were kind of reported well, not really. They reported kind of what land they fell on, but it wasn't great. So with these stones, the largest one, which is the one that a lot of people care about, right? It's the cool one that I have a bunch of pictures of, not these ones, these are smaller ones. But the biggest one was actually found 3 feet under a giant oak tree. It had cut through some of the roots and it had kind of lodged itself under there, which was pretty cool. So this thing was coming in at a very specific angle to get kind of wedged in where it was originally found. And that stone that we do have on campus is about 103 pounds. It is the largest stone that was found during this fall. It is believed to be the main mass of the meteorite that all of the other meteorites then broke off of, and that's how we get all of the fragments. So the sizes for these stones, they did vary quite a bit. So 103 pounds being the largest one, and then some of the smaller ones that we have are about half a pound. So pretty wide variation, which I'll talk more once we get to the actual mapping part. Pages. But yeah, so, and when I mean fragments, just to explain this a little bit, so when, I kind of already did, but the main mass, when it's coming in, those different bangs that we heard, so the 23 distinct bangs and it was falling through the atmosphere, that's all of the stones kind of splitting off of it as it comes in, because it kind of breaks apart. It usually doesn't stay one big mass when it's coming into atmosphere. So that's what I mean by fragments when I say that for future reference. But shortly after the fall, once all of these meteorites were picked up, they were then kind of further studied and looked at. And we're going to be talking about 3 kind of main academic journals that were then published shortly after. All of these were within a year when the fall occurred. So they're pretty important. So there's 3 main ones that we're going to be talking about. There were also multiple different kind of news outlets that did cover this as well, that did have valuable information that I did use during the project. Some of which I apologize if I pronounce some of these wrong. They're very interesting names. The Cadets Democratic Sentinel had some really good information about fragment locations and things like that. And then also the Marietta Intelligencer also did have some fun things to say about this. We're mainly going to be talking about these 3 articles because they're the ones that really did a deep dive on covering the fall just via science. A lot of them had main eyewitness accounts that were recorded in these papers that were very valuable for my project that I was doing. So without further ado, let's talk about some of them. So the first one we're going to be talking about was published from E.B. Andrews. Andrews was actually a professor at Marietta College during the 1860s era. He mainly did work with petroleum geology, as we're known for in Marietta College, is petroleum stuff, but he was one of the main folks that was looking at this meteorite when it first fell. In fact, he was the one who actually purchased the meteorite for the college for about $200, which is steal nowadays, right? But he was the one that did actually secure the main mass that we do have in Marietta, which is pretty cool. So in this paper, he was kind of the first to describe a lot of eyewitness accounts, which were very helpful. It talks about the angle that the meteor came from, how fast it was going a little bit. It also featured a lot of smaller excerpts from some of the other authors that we're going to be talking about within these next couple slides. Just little kind of tidbits to kind of preview those papers that they were preparing, which was really cool. Talked about that. Cool. Yeah. So this paper was very important for kind of understanding the first developments of the fall. Shortly after this paper was published, about 6 months later, there was a paper by J.L. Smith. Now, J.L. Smith, he is actually a chemistry professor, or was a chemistry professor up in the University of Louisville, Kentucky. And so he published this paper shortly after. Again, a lot more eyewitness accounts. He did a lot of chemical analyses on some of the fragments, so we do have data about that. So describe the meteorite as like earthy materials such as minerals and olivine and pyroxene, and then nickeliferous iron, or just irons with a lot of nickel in it. We now have better ways of describing meteorites than just this. I want to put that out there. We don't just say there's iron in it. Well, yeah, we knew there's iron in it. It's gonna be iron in it. But again, 1860s, I'll give him a little bit of credit. So this paper was, again, really important for figuring it out. But the main thing that I found in this paper was a lovely map, which this was really cool for the project that I was doing. And I can't tell you how excited I was when I first found this map, because this makes my job a whole lot easier because it shows all of the meteorite fragments right there on a map. So my job's done, right? No, and we'll talk about that more in a little bit, but so keep this in mind when we're going on a little bit. Yeah, so that was the main thing to kind of come from this paper. And then third and final paper we had from E.W. Evans. He was also a professor at Marietta College. I think he did more geology stuff. I'm not really sure. But he was also there working at the same time that Professor Andrews was. Again, a lot more eyewitness accounts. These papers also do cite each other a lot. So it's a lot of just repeat of the same words, but still very important. This paper did give a lot more context on the trajectory of the meteorite, and so it's using all of those eyewitness accounts to tell us how the meteorite came in, at what angles, at what height. So it was very interesting to read all of the math that he kind of used and put together via just people witnessing it falling. This paper is also where we get that 4 miles per second from, which again, it's very fast. So yeah, this paper, when I talk about the trajectory of the meteorite and kind of where it came in from, this did kind of help pinpoint, later on the map, you'll see I have a trajectory line on it, which is about 41 degrees west of north. I know it's a weird measurement, but just think north, 41 degrees that way. So that is an average because a couple of these papers did list slightly different things. So I tended to try and average the best thing from there. But anyway, back to this paper. The other thing that this paper really did was mainly call out a lot of the stuff in Smith's paper, because apparently it's horribly inaccurate. And I didn't know that at the time when I first read it, because I found the Smith paper before I found this paper. So that was great, basing a lot of the project off of that Smith paper and then finding this paper and being like, oh man, that's not great. But anyway, we're gonna save more of that for the next slide. But those are just kind of the three main papers that I used based off of this. Again, there are a lot of other resources that I did work with Linda Showalter down in oh my gosh, special collections, thank you. And just finding other random like one page documents, reading those just from various news outlets and things like that were incredibly helpful. So now kind of getting to what I did. So my first plan for how to do this, right, heavily utilize this lovely map that we have here from our paper, right? So my plan A was to create a web plot digitizer, which if you don't know what that is, it's this program where you can put in, like you can take a picture, put it into this thing, you can put a bunch of dots on it and then give values to those dots, and then it can put it into an Excel sheet and then you have data. So it'd be pretty easy. So I planned on using this map since I know the latitude and longitude lines, make a point there, give the latitude, longitude lines, and then I can use that to kind of reference where all of the other points are, and it would have been super easy. But no, I couldn't do that because there's so many inaccuracies in this map. The main ones being the latitude and longitude lines, which I was gonna use. They're wrong. So that 41 that's right there, I think this 41 should be down here or vice versa. It's not good. So when I did that web plot digitizer, it put it like so many miles more north than it was originally. And I was like, wait, that's not right. I know where these fell, and that's not it. So I did want to read this little excerpt that I have. This is from Evans' paper that ridiculed the Smith paper, right? So it says, On the map contained in Professor Smith's article, the lines of longitude place the fall of the meteoric stones a full 60 nautical miles further north than really occurred, while Parkersburg, the place of the most important observations, quoted by him, is placed too far north by about 37 nautical miles. Such errors, if allowed to stand uncorrected, would involve the whole subject of the meteor's path in confusion. So highly recommend, if you love scientific drama, read this Evans paper because it is juicy. There's so many other places where he's like, this is incorrect, and and it was very interesting to read. But yeah, so that was on my plan A. Didn't work out so well. So I had to kind of switch it over to plan B, which instead of using that lovely map that would have been so easy to do, I had to then do the hard way. So all of the meteorites had, when they fell, they recorded what farmland they landed on. So here we have a lovely list of names, which I'll talk about that here in a second too. We have the weight of each meteorite, which landed on, I guess, and then just an arbitrary number that was given to it when it fell. What I could do with this is I could find where those plots of lands were, and then figure out where the meteorite was within that plot of land using all of the papers that were given to me and all the news articles and things like that. So a little bit more difficult, a little bit more work involved, but that's okay. One of the things that I'll talk about kind of towards the end with the challenges and stuff, which if you look at this list, and if these names look familiar, it's okay if they don't. But some of these are misspelled and they're not the correct name. So for example, Phyllis right here, that should be a PH instead of an F. So that made it more complicated to try and find the land that it was on. Another example, Shenholt at the bottom should be like Shineholt. And that's spelled incorrectly as well, which is not great for if you're trying to find plots of land with very specific names and they're misspelled. So what I ended up doing, so this meant I had to find where the land was, right? So what I ended up doing is using maps, right? So all of these are old ship maps from the darker brown one here is from 1855, and then all of the colored ones are from 1870. They're from old historical atlases that list a bunch of like tax information, basically. They also have all of the property boundaries on them and who owns that specific property. So yay, easy, right? No, because if you heard me correctly, this one's from 1855 and the other one's from 1870. This fall happened in 1860. Not easy anymore. So I wasn't able to find a historical atlas that was the correct year. So I had to do a little bit of like puzzle piecing together with my maps that I had available and the names that I had available. So what I'm doing, I'm going to walk through this process here to show you kind of what exactly I did. So you can see what I had to deal with. But anyway, here we have just picture of Guernsey County, right? This is the county where a lot of the meteorites fell. So we have that in ArcGIS mapping software that we used for this project. We're able to import pictures onto here, which is very nice. So what I did, I would import a picture and make sure that it lined up with those county lines really nice. So that looks something like this. So I know you don't believe me because it's a solid picture, right? But trust me, it's lined up. And again, this is a PowerPoint. I did it much cleaner in the actual thing, I promise. But this is what it kind of looked like. So this is that 1855 map, all lined up, perfect. But with this 1855 map, I didn't have all of the property names. So I guess I should probably say the main place that I'm going to be looking in is Westland Township, Jackson Township, Valley Township, and Spencer Township. There's all kind of in this bottom corner right here. So that's kind of where I'm looking for these stones. And this map, it is higher quality than it shows on this projection. So I could actually zoom in and see the names pretty clearly. It was a little bit fuzzy, which you'll see here in a second why I don't have it super zoomed in for this one. But I was able to see the names pretty clearly and make out some of them. But again, this one didn't have all the names. So what I then did was layer one of those township maps over where I had the main townships, right? To make it easier. And from there, I could then puzzle piece, okay, what names am I missing from the 1855 map? What names am I missing from the 1870s map? And do a little bit of kind of investigative work to figure out, okay, what's missing here? What land got sold here and nobody recorded it, or what like subletting of land happened here, so it's under a different name that wasn't recorded in the main papers, things like that. So it was very interesting to kind of just see all of that. Plus finding like the historical atlases and like getting to read them and see like all of the people and stuff who owned land was very fun as well. Nice history aspect of it, I guess. But once we had all of those laid out, I was then able to figure out, this is a really zoomed in picture, ignore the blurriness, I know it sucks, but I promise the resolution of when I actually did this was a lot better. This is just what I put in PowerPoint real quick. But this is all zoomed in, so what I ended up doing to actually make the property boundaries is you can see them right there, little squares that are kind of everywhere. So I would just take box tool, line tool, whatever you want to use, draw a little square around it, right? I'd name the figure that I just made or the polygon that I just made. So I'd say, okay, that's so-and-so's land. So that's so-and-so's land. Cool. That is now associated with that box. Easy peasy. Then I could do other ones. I think there's 22 boxes on my footer, which you'll see here in a little bit. Well, I did that tons of times, using both this map and again, the other map, and then the various different townships, things like that. And then once I had those property boundaries laid out, I was then able to figure out where the heck the points went, right? So this was not super easy as I wanted it to be. A lot of the point data, well, none of the point data had like very specific latitude, longitude lines associated with it, which would have been super easy, but no, they don't keep those records in 1860. So I had to go off of just the description that was given to me in these papers. So some of them, for example, would be like, oh, this one's like 300 feet away from this church. And it's like, okay, well, I don't know where that church is, so it's somewhere over here. Or this one's 100 feet away from so-and-so's house. And it's like, okay, well, where's so-and-so's house? I don't know so-and-so, like it's 1860s. I don't know that. So there's a lot of, not guesswork, but a lot of just trying to figure out where the points would go within the property boundaries. So I tried my best to kind of get them right in the same spots. And as you'll see on the map here in a little bit, some of them actually aren't in boxes because I wasn't able to find that property, but I did know kind of the relative location of where they were. So that was a big help, again, from all the papers and doing like literature review, things like that, that I was able to kind of piece together. So yeah, once we had that, boom, there's our points, easy peasy. Or not, but yeah. And then we could remove the map and then voila, there's our current map, right? So here's my final map. It's getting covered a little bit by that. That's okay. It's very pretty. We can see the red point data is where all of our fragments are. The brown boxes is where we have all of our property boundaries. And then that line that I talked about, that's our trajectory line. So that's where the meteorite actually came in from. And then the red ellipse around it. So in geology, there's something called a strewn field, or not geology, planetary science. There's something called a strewn field, which is basically just an area of probability of where fragments from a meteorite fall are most likely to be found. In the papers, they listed this as a 10-mile by 3-mile area. When we mapped that though, it was way too small and most of the fragments actually didn't fit within that area. So we did double out a 20-mile by 6-mile area. And it does encompass all of our fragments that we have there, as well as any potential fragments that weren't found during the initial fall, which is very unlikely. So don't go running out to Guernsey County trying to find meteorites, but who knows, they could be out there. But anyway, so our lovely point data that we have on here is symbolized or just arranged in a way by weight. So we did have the weight for each of our fragments recorded according to their property data. So I was able to do, again, not a little bit of guesswork, but my best estimate of which weights went to which meteorite in which property. So we have bigger ones for bigger weights and smaller ones for smaller weights. Let's see. In this map, you can kind of see a pattern if you're really looking for it. In the top left, you do see a lot of larger fragments, and then toward the bottom right, you do see a lot of smaller fragments. So this is due to when meteorites are coming into atmosphere, they tend to lose a lot of little stuff first, and then like the heavier stuff just keeps on going. So it does kind of track with things that we do see during other falls and other strewn fields and things like that, which is pretty cool that we can see this in ours. So it's a very fun kind of development. And yeah, again, just pointing out that the fragment location, so the point data isn't going to be as accurate as I would have liked for it to be. To do that, I would have had to have data that I did not have. But the property data boundaries are pretty accurate. I try my best to get everything lined up the way that they should. So those should be pretty good. So, but yeah, let's see what else we got. Overall complication, I kind of talked about this throughout the talk, but a lot of misspellings, just throughout the papers, a lot of misspelling is people's names. There was actually one instance where there was a misrecording of someone's name. I'm assuming one of the papers they had listed the guy's property, but the name that they listed was actually the guy that found it, and it wasn't his property. So that was kind of interesting that they had recorded it like that. I don't know why, just errors happen. When rocks are falling from the sky, it's scary. But again, our descriptions were very limited in this. So it wasn't, I would have loved latitude, longitude lines, but I don't know how they would have precisely recorded that per se. So I got a lot of the examples that you're seeing down at the bottom. So they fell 300 yards from so-and-so's house. They fell 2 miles from the Walls schoolhouse, which that was apparently a schoolhouse. It's actually marked on one of the maps. So if I go back here, that little itty bitty dot, that's right down there. That's about 200 yards from wherever that schoolhouse is. I was able to find it. It's kind of right in this intersection between all of those property data points. That's right kind of to the northwest of it. But I drew a circle, and guess what? That's 200 yards somewhere southwest of it. So it could be kind of anywhere along that curve right there. But that's where I put it, just for funsies. So it's there. But yeah, so those were kind of just some of the complications with this project. It took a long time. What I kind of ended up doing to find the property names is actually printed out, or Linda printed out these huge maps for me so that the names were super blown up, and I would go in with pen and I'd draw all over them and be like, okay, this is so-and-so's land. We got that. Okay, now where's this one? And then I realized it wasn't in the right township. So I had to find another map and print off that one. And it was a whole process. But end result, I think it's pretty good. We get kind of a general area of where all the fragments fell. You can kind of figure out where exactly they were, but it's pretty cool. And then some of the main goals and applications of this, I did want to make stuff like this more accessible to people like you. So this map is actually available to the public. That's what this lovely QR code is, which I can put up again at the end if people really did want to look at it. But this makes it kind of a lot easier to visualize this data. That's the whole point of GIS, right? Or geographic information systems, is to turn numbers on a page into something that people can look at and really understand. While some people can understand the numbers, a lot of people struggle with that. So looking at a map is so much easier than just looking at just numbers in an Excel sheet. So it's really handy dandy. The other thing that I kind of wanted to help with a little bit is we do from time to time get people coming to the geology department saying, I found a meteorite, and it's like, okay. But if the off chance one day they do find a meteorite and it's within that little strewn field ellipse that they were in, we could say, okay, if this is a meteorite, after we do some testing and it fell in this area, it's probably part of this meteorite. And then other petrographic and chemical testing can confirm that. If again, it's just a meteorite, a lot of the time, I have yet to see someone who's brought in an actual meteorite. So we've had a couple really optimistic folks, but that's okay. I appreciate their enthusiasm. They're so excited every time, and it's like, but yeah. So I guess that's my whole project. I was a little fast, but that's okay. More time for questions, right? So with that, thank you so much. Here's a picture of it in our lovely showcase down in the Brown Petroleum Engineering Building on campus. If y'all want to see this in person, you guys are more than welcome to come down whenever. The So it's right in our main office. So if you go in the building, it's like a split level. It's really strange. So if you go up the main stairs and then right to the left is our main office, it's like front center. So you can't really miss it. It's a big rock on a, there's usually lights shining down on it too. It's like, so it's pretty cool. But yeah, I would have brought it with me, but it's a little bit heavy. So, that would have been a trek, but we're like, there you go. It's like, oh, but yeah, with that, and I put my email up there. If y'all had more questions after this that, or if we don't get to within the next 25 minutes, I'd be surprised if we don't. But if you had any other questions, or if you did just want to come check it out, feel free to. So yeah, thank you guys so much for listening.
Well, at this time, we'll go ahead and start with questions in the room. And for folks online, if they want to chime in and put that into the chat or the Q&A, we'll go from there.
Yes.
You may have said this, maybe I missed it, but is this specimen at the college, is this the largest one? Or-
Yes, this is the largest one. Yep.
And what's the weight?
103 pounds.
103. Okay.
Yes. It's a very specific way to know it, so it's fun to
And
say.
is it an irony for, as opposed to a stony?
So this, that classification is interesting. I think this would be, using that classification is more of a stony meteorite.
It looks more stony.
Yeah, its technical classification is called an ordinary chondrite. It's just very specific meteorite terminology. To get even more specific, it's an L6, so it just means it has low iron. That's what the L means. And then 6 is just classification. I don't know the whole, that's different meteorites than what I work with and that I'm used to. So, but yeah, it's not an iron. I do know that. If it did, it would be a lot heavier. So, yes.
How do they figure out how fast it was going?
I would assume through very careful observations. That's something that I don't really know how they got that number from, but I'm assuming there's math that was done. They do also list very specific angles in like that Evans paper that I was talking about, like very specific angles, not like rounding up to like 5s or 10s. It's like 37 degrees. And it's like, well, how do you get 37? So it's very iffy. Again, 1860 science. So I don't know how sciencey you can really be. I'm sure you could do a whole lot, but just with eyewitness observations, it's really hard to. I know nowadays when we have cameras and stuff, it makes it a lot easier. So you can record it too, so you can see it multiple times, and then from there you can do, if you know where the camera is, you can then do math that I don't know to figure out kind of how fast it's going and the angles and things like that. So. Yeah, that's a good question. I don't know how they figured that out, but I trust them enough.
That's just wild that you could figure out how fast something was going based on what people are telling you.
Yeah.
They saw.
Yeah, which is very shaky, but I mean,
They're doing their best.
yeah. Yes.
Following up on the speed,
Mhm.
when this large piece hit, was there some sort of freighter or I can't see the universe. I don't know how large.
The ruler. Oh, this thing's about like about a foot wide. It's pretty big.
If you said the speed of sound is 0.2 miles per second.
Yes, I did look that up just before I came here, so to have something to compare it to.
Per second.
Yes.
This is traveling at 20 times the speed of sound, which is
Yes.
14,000 miles per hour.
You doing this math all in your head? That's impressive. My goodness.
She's
Ah.
the double.
Okay. Okay.
Well, it's not like it's
Just. And if you're traveling at
Yeah.
like a massive
Mhm.
crater, and then that is how the founder, the buyer,
Yeah.
he might have found it. So I'm wondering, again, the speed, whether there was a gigantic
Mhm.
crater, And how did he identify that he wanted to buy this
Yeah.
particular specimen? Do you know anything about that?
Yeah, so again, the speed, I don't know about that. So I have no clue how they calculated that. That's just what was written in papers multiple times. So I can only trust what they have written. Again, I don't know how accurate that is. Again, 1860s data. I do know that there wasn't a huge crater. I think I touched on this a little bit, but with the angles that we have recorded, this thing came in at a pretty shallow angle. So if you're looking at an impact crater, if it came in like more like this, it'd go out, right? This thing, since it also got wedged under a tree, it didn't really form a crater. It just kind of, since it came in at a shallow enough angle, it just kind of got wedged under there. So it did cut through like some two pretty thick like tree roots that I read about, and then it got stuck kind of on the third one when it did come in, which is pretty interesting. So it was just kind of sitting there. It was about 3 feet underground when they found it. So I'm assuming there's a pretty big hole that was left by and some dirt that was overturned. Sure that tree took a beating a little bit too, but I hope it's fine. But yeah, so that's a lot of the thing with doing a project like this is like you don't know. So you can only kind of trust the papers so much. So yeah, but no, that's a good question.
Well, I have one online from Sarah,
Okay.
who said that she is a Marietta College history major graduate. Greatly enjoyed the research presentation. Do you know what happened to the other meteorites that weighed 50 pounds, et cetera? Do other universities or museums own them?
Yeah, I know the Smithsonian owns a fragment of one. I know a number of different institutions own multiple. I think some museums in Europe also have fragments of them. I don't think any are in storage at Johnson Space Center. I think Arizona State might have a fragment as well. I am not 100%, but I think it's in their meteorite database when I looked it up. Yeah, they kind of got all flung around. Also on my map, I believe I have 24 fragments mapped. A lot of the papers say that there were over 50 that ended up falling, or not 50, over 30 that ended up falling. I don't know where the other 6 went, if they said that over 30 fell.
Attic or, you know.
I guess, I don't know. So there's some that are just somewhere in someone's like toy box, or I don't know. But yeah, they also listed, which I thought was pretty interesting, and I don't know how they got this number, that there was about 700 pounds of meteoric material that fell during this fall. But if you add up all of the weights of the fragments that I had mapped, it's something like 400 something. So again, I don't know where they got that 700-pound number from, but it's listed multiple times throughout these papers, which I think is very interesting. So there's very well probably just more fragments that either weren't recorded in these papers or just people have found kind of a thing. You're like, no, you're not taking my meteorite. So I don't know. But it's very interesting. I can only work with what is recorded. So there's probably a tons more that just wasn't. So
Was the 700 maybe the original, what they estimated before it started going through the atmosphere, and maybe
the papers don't really specify. It
they
just
don't know how
said,
big the original one?
yeah.
Okay.
Yeah, but it's very interesting sort of math that they did in these papers. So
Okay.
yes.
And, do you know if we've had any other observed meteorites in the region here? Any chance?
I do know throughout Ohio, I think we have 15, it's either 15 or like 20-ish meteorites that have been found within Ohio. It's not really anything like crazy. So meteorite, when they fall, it's random where they're gonna fall. Like you can't really predict, like there's one area that has more meteorite falls than another area. Like it's not how that works. But as far as like within close proximity to like Marietta, this is definitely the closest. It's only 45 minutes away. So but yeah. Yes.
So you looked at some newspaper accounts too, and I'm
Yes.
curious if there were any, I don't know, out there explanations for why people thought this happened or what it might be. You know what I'm
Ooh.
saying? Like conspiracy theory or.
End of the world.
Yeah.
Yeah, right, yeah, a little apocalyptic.
You know, a lot of papers that I read, weren't like that. So at this point in time, meteorite falls have been recorded before. So they're pretty well documented thing at this point. In fact, a lot of these papers represent a meteorite fall that happened in France, I believe, just a couple years beforehand. And a lot of them directly compare them to like the composition of this meteorite. They're like, oh, it's the same. It's not the same, but they're very, very close because there's very similar types of meteorites. So this wasn't, I mean, for the townspeople, yeah, it's like there's rocks falling from the sky. What the heck's going on? But then you have people come and be like, no, there's meteorites, it's fine. So in any of like the papers and stuff that I found, there wasn't anything like the world is ending. Ah! So, which yeah, that is a pretty interesting point that like there wasn't really anything. I'm sure there were probably some that just I didn't find. Again, 1860s stuff that could have gotten lost since then. But yeah, no, most of them were pretty good at staying kind of science related. So a lot of them quoted the E.B. Andrews paper a lot. So it's just a lot of the same kind of words that I was reading when I was doing, which is a little bit annoying when you're trying to get more data, not the same of one specific sentence. But overall, yeah, no, it's pretty clean, I guess. Yes.
I know this is gonna sound very peculiar. but
No, you're good.
The newspapers that you read,
Yes.
and this is generally a rural farming
Mhm.
area. Were there any accounts of how farm animals, cows, horses, reacted when this must have hit the ground and this tremendous sound that sounded like a meteor hit?
Yeah.
And, you know, something that they said felt like an earthquake, it could be felt as far away as Marietta.
Mhm.
Any account of how farm animals reacted?
Yeah, if there was, it wasn't recorded, or I didn't find it. I mean, if that horse got hit with one, unfortunately, I bet it reacted, but otherwise, otherwise, no, there wasn't anything in papers that really specified like, oh, these sheep were going crazy. Like, so it's for the most part, it stayed pretty consistent again to like, oh, the fall, the trajectory, the where they landed. So yeah. Sorry to disappoint you, but
We do also have another one online from Krista. How
Ah.
do you determine what is a meteorite and what is just a rock?
yes, well, hello, mother. That is my mom. So that's so, how do you determine what's a meteorite and what's a normal Earth rock? Very great question. Well, one, in this case, you could see it falling. Earth rocks tend not to do that all too much. And if they do, there's a problem. But anyway, so how to differentiate a meteorite versus an Earth rock? One, their composition. So meteorites tend to be very rich in iron and other heavy metals. So that's kind of like your first step to kind of go, okay, well, is this iron rich or is this just a bunch of like quartz? If it's a bunch of quartz, guess what? It's not a meteorite. So it's very iron rich. Then you kind of got like your first kind of stepping stones. Further with that, we can do chemical analyses, a lot of petrographic studies, looking at the different minerals, really in depth. So part of what I do is taking meteorites and cutting them into well, I don't cut them, NASA cuts them, so I don't mess it up. Cut them into really thin slices, so they're about thinner than like a sheet of paper. We can put them under a microscope that has special light going through it, and then we can see all the different types of minerals that are in them, and they tend to be really pretty depending on which ones you're looking at. So the ones that I look at are very pretty. So you can do that. You can compare them to earth rocks. A lot of them will be very similar to earth rocks if they're the same type of rock. So for example, the rock basalt, if any of you know geology, if not, that's okay. Basalt, you think just volcanic rock. So a rock that comes from a volcano, right? We have most, if not all meteorites are volcanic rock material. So they tend to look pretty similar. We can then do further studies. A lot of meteorites tend to have gases trapped in them if they did come from something like a parent body. So we can do isotope analyses on the gases that are trapped within the rock. Again, if they come from a parent body, and kind of tie that back to where they originated, which is pretty cool. For rocks that don't come from parent bodies, in space, there are these things called galactic cosmic rays, and they're constantly like blasting stuff. So rocks that are in space will have kind of indicators of that. Rocks that are here on Earth, since we have a lovely blanket called the atmosphere, we don't get a whole lot of those. So you'll have rocks that have kind of indicators of that. You'll be like, whoa, that's not from here. So it's kind of another way. There's multiple ways that you can kind of figure out this isn't from here. For this one, it's very obvious. They saw it falling. But for some other ones, it can be a little tricky. So
Except this was a low iron one, so that's a little bit more on the tricky side.
yeah, a little bit. Another thing is all meteorites would be magnetic because they have a lot of iron, or most, if not all. I believe most are though. So if you stick a magnet on it, it'll stick.
Okay.
Then again, a lot of meteorites do get confused with like industrial slag. So because it can look kind of very similar. If you're like, oh, a hunk of iron that I found, it's not supposed to be there. It's like, well, if you're near a factory, guess what? Probably came from there. But yeah.
Other questions? Yep.
So, I'm just wondering, well, this maybe, sometimes it's a high pressure question, but
Mhm.
do you, what are you looking to do after you graduate?
Yeah, so I do want to go to grad school. I'm looking at, I don't know where yet, but that's okay. I got like 6 months to figure it out, right? Before I start trying to apply to places, but that's okay. Got a couple schools in mind. I really like the meteorite stuff that I've gotten to do here, and I'm hoping to continue at through my capstone project that I'm starting right now, which is very fun. We got samples a couple weeks ago, so I've been starting to look at those. They're very pretty. But yeah, just getting to work with anything space rock related. I really enjoy the looking at rocks and minerals in depth and figuring out, okay, well, what's in this rock and what, like, looking at it, how do we know, okay, how that formed? And then also by looking at it, we can sometimes know where it came from. And then if we know how it formed and where it came from, that can tell us more about like the main parent body that it came from and how that formed. So it's very interesting stuff. But yeah, I do want to go to grad school, get PhD eventually, and then hopefully find a job, right? Afterwards, so.
But you're interested in continuing with meteorites, it sounds like.
Yes, meteorites are kind of anything igneous. I'm a fan of igneous rock stuff. I'm not too good at sedimentary rock stuff. But igneous metamorphic-y stuff, that stuff I can do okay, but yeah. Yes.
Oh, go ahead.
Go.
Shine the light through the meteorite when
Mhm.
you're looking through the microscope. Are you using like a spectrograph to look through that? Is that the same thing, like the same type of thing, like when you're looking at like stars through a telescope, like?
Kind of. So the microscope that we use, it's called a cross polarizing, or a oh my gosh. Petrographic microscope. So it basically shines cross polarized light. So, oh my gosh, mineralogy is gonna. So if you have light, it's going in one direction, right? You usually have, one thing of light going up. When you put a cross polar in, it splits the light and then it can either speed it up or slow it down. And then once it goes through that, it'll come back together and you can see different colors based off of how much it's sped up or slowed down. And so the different colors can then tell you what minerals you're looking at. Minerals do have like a slight range in colors. But that generally gives you, along with a bunch of other factors that you look at for specific minerals, can tell you what you're looking at. That's petrographic microscope stuff. There is other analytical techniques that do use spectra that you're talking about. I haven't worked with them a whole lot because I'm starting out with this, but I do know of them. So, yes.
Are you planning to take this research and deliver it or submit it perhaps to a conference? Geology, GIS,
Mhm.
undergraduate research?
Yeah, so funny that you mentioned that. I've already presented this at a conference before. I presented this at the Geological Society of America conference back in September in Anaheim, California. I did a poster presentation with this along with another project that I did. And I'm actually presenting this again at the Lunar and Planetary Science Conference in Houston in a couple weeks now. So thank you. Yeah, so it's very exciting stuff. I like talking about it. The projects I get to work on are pretty cool, and I like sharing them with folks. So yes.
I wanted to mention first a castle artifact I think you would be interested in.
Oh, yeah?
On the very back wall, in the castle,
Mhm.
there's a huge map. It's an 1858 map
Mhm.
of Washington County. It's huge.
Oh, fun.
Has all the little plots of land with names and so on. So you might be interested in that, even though it's not
Mhm.
really connected to your presentation, but it is a map.
Yeah.
The other thing I wanted to ask was, I know that as Ohio developed as a state and so on, boundary lines of counties changed. I mean, for example, Washington County originally, and Scott's talked about this a lot, was
Mhm.
huge. Is this map that you had of around 1860, the final boundary lines? And maybe Scott, you know something about that?
Matt's probably the expert on this, but yeah, these particular counties were all formed. And their final boundaries, I don't think, have changed since then.
Yeah, I was gonna say, any of the maps that I looked at were pretty spot on with the final shapes that we see today, so I didn't really have to worry about that too much, thankfully. That would have been a whole other thing that I would have had to worry about.
If you go further back, then you have different counties breaking off and those type of things.
The original size of Washington County was, well, Scott, you could.
Yeah, it goes clear to Lake Erie. So.
Oh, gosh.
I do have another online question. Andrew said, great presentation. I was able to hear about the project that when you worked on it last year, pretty fun project. What kind of tests can be done on meteorites like this one that fell centuries ago? Since I assume you don't want to do destructive tests on them, you want to preserve them. Does that mean that some of the information will never be obtained about them without destroying them in some way or another?
Yeah, so first off, hi, Andrew, that's my boyfriend. I got a lot of people back home watching this. Yeah, so we can do non-destructive tests, so things like looking through a microscope to figure out the different minerals that are in it, different ratios of minerals that can kind of be used to figure out for a very baseline kind of what we're looking at. You can also, again, there are a couple other non-destructive analytical techniques that will give you a better idea of the different elements that are in the sample, along with a better kind of estimate of different minerals. For a meteorite like this, since it is so big, to get an in-depth analysis, you don't have to, like, you can do destructive analysis techniques with it if you take off a small enough piece. For a lot of the analysis methods that we use in planetary geology, you're not using a huge hunk of rock, so you're not taking that 103-pound mass that we have, grinding up the entire thing, and then analyzing the entire thing, because that's a no-no and it's frowned upon. So you can take like a little like sub-gram sample of it, analyze that, and get some of the answers that you need. So.
With that, we'll finish. That'll be the end of the Q&A, and I have one little thing. Let's give a round of applause. I'm gonna finish up and thank everyone here. Yeah, thank you very much. That was really good. Just wanted to finish off by saying, thank you all for coming out. A little bit of a preview for a few minutes here. Next Saturday, Katie and several others are going to be coming for our School of Magic and Wizardry, which is an all ages kind of a fantasy type of thing. Not to be confused with that guy that flew around and did Quidditch and all those type of things. Yeah, it's totally different. It's totally different. It has a beginning session about 10 a.m. to noon, an advanced session from 2 to 4. Students can learn about the magic of the castle with a history of magic lesson, care of magical creatures, and a new class this year about astronomy with Francie Bolden, who works down at the planetarium here at Marietta College. And the registration ends next Wednesday. And for those in in person here. There's flyers on the back and others can find it online. Our first food history of the year will be Tuesday, March 18th at 6 p.m. Just down from the castle at St. Mary's Basilica at the social hall. Registration is required and tickets are already going quickly. This year's topic is going to be, or this particular topic is going to be the history and influence of Scottish culture with our speaker, Dr. Barbara Mahaffey, retired Marietta College professor, and Dr. Timothy Anderson at Ohio University. It's a 3-course dinner with Scotty that always is great fare in conjunction with the cook shop. And our highly popular spring tea will take place on Saturday, April the 12th. An announcement will be sent out to our members first before we send it out to the general public. So if you aren't a member, now's a good time to look into that. You can do some of that either online or here in person. You can sign up for membership and get some of those discounts and other benefits, like getting this opportunity to sign up early for those highly sought after spring teas. And any of the programs that we have coming up this year, you can go online and take a look at those. Membership, volunteering, all sorts of other things. We're in the process of doing a capital campaign. We received a large grant from the state of Ohio, and we're trying to finalize the community portion of donations for that particular endeavor, a little bit under $200,000. We're going to replace the roof on the main Castle Museum in 2018, and all the remaining buildings, the slate roof for those are going to be replaced, as well as some repairs on our cupola at the carriage house, and brand new gutters and downspouts that are more historically accurate to the time period of the house as well. So if you'd be willing to help us out with some additional dollars to help to fund our portion, our matching portions for that, we would appreciate it. Again, thank you all for coming here in person, and thank you all for listening and the questions that were added online. And we hope to see you again soon, and for a future program of Third Thursday and many of the other offerings that we have here. So thank you very much.
Great.